Hello everybody, it is the second live stream of the Shiny Developer Series. So welcome R enthusiasts, Shiny enthusiasts, maybe general Linux enthusiasts, and perhaps even some racing fans. Welcome, and we're going to have a lot of fun on this stream, and we'll just kind of get right to it. First, there are definitely links below in the description if you want to follow along with some of the apps and the code that I'll be showing off. But yeah, I want to thank everybody that tuned in to the last one that I did about a couple months ago. It was like really well received, and happy to hopefully keep this going. So let's not wait any longer to say hello to our chat room. Hello everybody, and come say hi, don't be shy. This is a very welcoming group here, and so I want to say hi to Monica. She is one of the fellow racers that has been having a lot of fun with me the past few months on this. And hello Dean once again, glad you can make it. And yeah, don't be shy to ask questions or chime in anytime. So now I'm going to set up kind of the situation here. It's kind of a long story. I'll try to keep it brief, but I think it's been a lot of fun to get here. So I kind of alluded to it maybe even in the last stream or maybe in some other venues. Boy, did I work pretty hard at the end of last year. I was at the day job. I was finishing up, I think, 3 production kind of Shiny apps and pipeline stuff all around the same time. And boy, that took a lot out of me. So I really enjoyed having that time off. And it was around that time that I've become part of a very fun community led by Martin Wimpress, who I mentioned in the last stream, who's been kind of guiding me to see the light and how to do this awesome streaming stuff with OBS and everything. Well, he kind of started an unofficial kind of gaming night every so often. And one of the games they started to play was this really fun racing game called Hotshots Racing. And so I purchased it. It's available on Steam for all the OSs. And if you're on Linux, it works with Proton. And it reminds me so much of the retro racers I played at the local arcade. In fact, not too far from my house growing up, we had an arcade called the Fun Factory, which is a real fun name, right? Pun intended, I guess. But I spent a lot of quarters in a lot of the racing games there, and particularly, I remember Virtual Racing and Daytona USA. Oh boy, I had a lot of fun with those. So this game in particular, this Hotshots Racing, is really kind of giving me those retro vibes back. And so going back to kind of the group I've been playing with, Martin has started doing some streams of this, and he invited a few of us in the community that he has called Wimpy's World to join him for online play. And so I was like, yeah, I gotta try this out, see how it goes. So I ended up joining for a couple of them, and yeah, it's highly addictive, very addictive. And then it started to become more of a regular thing for our group. And so they kind of thought, well, why not have some fun with this and kind of make our own Grand Prix of this, where we're all just kind of competing against each other and, you know, may the best racer win, so to speak. So I've started to join a few of those, and we started our 2nd season of it, I believe, last week. And yeah, Monica, it is highly addictive. I probably don't want to say how many hours I put in, although I'm not close to Martin or Yannick, so you'll hear about Yannick in a little bit, some of the stuff he's setting up. So I wanted to kind of show you a clip of last week and this kind of stream in action. And let me flip some bits here and see if I can do my... Okay, so, well, first a little follow-up before we dive into the racing stuff. The last stream, if you didn't catch it, was talking about my new development environment for coding up R projects and Shiny apps on my my new hardware here at home. It's very based in Docker containers and with customized R environments, with package management, with REnv, and I'm able to pivot between Visual Studio Code with the R extensions and RStudio Server and kind of use each of them in different ways. So if you missed that one, you'll want to check that out if you want to kind of see when I start getting to the code here how I set all this up. I want to thank one of our viewers from last time who saw some typos in one of my sourcing functions for the plot, kind of the plot setup in Visual Studio Code, because one of the packages got updated without me knowing it, or I didn't check like the few days before the last stream. And so Richard here was kind enough to correct those references, and I merged into PR. So another reason why I want to do this is we all get to learn together and contribute to each other. So thanks, Richard, for that. So everything's working just great now with my development setup. So, okay, let's have some fun here. Let's play a clip from last week, and about towards the end of one of our first races. But it was a lot of fun. So this is from Wimpy's stream, which I'll have a link to in the description below. Let's have a listen in. You can see we have a lot of fun during this. That was my voice there, by the way. So this is Martin's car. He's frantically trying to finish.
If we finished.
Now, listen for a special guest here in a little bit.
Yeah,
that's the first time ever, guys. Yeah.
Really?
So, I had a companion with me watching that. And I had never won first place in any of our races online until that very one. So he was very excited for that. So now, as we were kind of setting all this stuff up, we decided to change the rules a little bit, and one of them was to have all of us use the same car, because in Hotshots Racing you can choose from 8 drivers. Each of them have 4 cars, and they're all kind of different stats of like, are they balanced? Can one like drift or turn more? Can one accelerate more, or could they have like a higher total speed? And so we thought to make it interesting, we would all choose the same car, but we would randomly have the car chosen. Well, being a statistician in data sciences, I hear random and I'm thinking, oh, I can help with this. So in one of the streams we did before this league kind of kicked off again, I would actually have an R session on the other monitor with simply choosing a number between 1 and 8 for the driver, and then choosing then a number between 1 and 4 to correspond to the different cars. And sure, that works fine. I mean, I could just run ran unif or just a sample function and be done with it. Well, come on now. Let's have some fun with this, right? So of course I'm going to make a Shiny app out of it and make it the most over-the-top random car selector you'll probably ever see. So I'm going to show you the app first, and then we'll kind of dive into the code behind it. And then there will be another kind of the second half of this stream here. I'm going to talk about how we're capturing the data after each of these races, and how I'm kind of keeping some stats on this, because of course we get stats. I'm going to keep the stats. So let's have a look at the app real quick here. And oh, sorry, I meant to get the chat back here. Okay. So this is it. I've called it Wimpy's World Hotshot Racing Driver Selector, because who doesn't want a huge name here? It did get cropped up a bit. Let me go back here. And so I got a little stuff at the top describing this, and I've got 3 buttons here. The first one is what we're going to do first, is called Launch, and this is going to kick off the selection process. So let's go ahead and hit that. And we're spinning some stuff here, and then we have selected the driver Aston with his Avenger car. And so let's imagine that we were going to do a race. This would be the one we pick in the game after seeing this. And then I keep track in a table below here the different stats associated with the car that was selected. And so each car, as I mentioned earlier, has like a speed stat, an acceleration, and a drift. And you can see for this one, the speed's great, but the acceleration is not so great. It's on a 1 to 10 scale. And the drift is kind of, above average a little bit. And so after the one race is done, we can run this again. And then we just hit launch here. And then keep going, and then we got Marcus with vector, and then that is now recorded here. So that's pretty cool. And then we can also do an advanced settings switcher or dialog here, where we can determine how long it takes before it gets to that selection. That's really more of a cosmetic thing, I guess. We can do the random seed, and then we can also, if for whatever reason we just did not want a certain card to ever show up, we could simply check one of these, and then it would be excluded from using those in the future for the selection. So again, this is completely over the top. I acknowledge that already, but I thought it was a fun time to play with a couple different things here that, if you're noticing, I'll just dismiss this for a second. First, I got this cool background here, which was taken from a screenshot of the game, but the colors that are used throughout different parts of this, yeah, Monica, we might, maybe get Martin to get convinced of using that option. Yeah. You notice the theming of this is actually pretty nice. It's got colors, and why I chose these colors is because these are the ones that are coming kind of from the game assets. And another reason why I wanted to get these kind of colors is that there's one of our fellow racers in this group. He goes by Yannick Murray. I don't know if I'm pronouncing your name right, Yannick. But he is doing some development for all this stuff too. So I think we're having like an unofficial competition who can create the most random software development bits for a virtual racing league. I mean, he's got a head start on me, but I think I'm catching up a bit. But he had created basically a web version of the table to keep track of our progress. And here's like the GitHub version of that table. I'll show it here. And he themed it just like kind of what you would see in the game. Now, I thought that was really creative. How can I do that in Shiny? Well, the first step for me was to actually find what these colors were, because I'm not that strong in web development. I can't like pick that hex code from the image itself. But then I found this cool little site. I probably didn't put a link to it, but I'll go ahead and put a link in the chat now if you all want to see this. There we go. This is a cool little thing where you can upload an image, and then you can highlight over your cursor and get the hex color code for a given part of the image. So I could get the yellow color, the darker blue, the lighter blue, maybe the darker yellow, and all that. So, okay, I've got these colors. Now, what's an easy way to get my Shiny app to kind of be themed with all this? Well, for those of you that attended RStudio Global, which was our studio's annual conference that was virtual this year, back in January, if you were part of like the Shiny Birds of Feather kind of virtual sessions in between talks, which I was helping to, moderate is a strong word, but just kind of helping get people connected there. Everybody was raving about a new package that has come in the Shiny ecosystem called bslib, which as of Shiny 1.6, which just hit CRAN the other week, you can now use bslib to have a very concise way to theme your application. And so this is all kind of happening around the same time. And I thought, oh, I've got to play this. I got to play with this myself. A lot of people were kind of itching to find some examples. So this little glorified, racer selector is my first attempt at using bslib. So let's go ahead and start diving into some code, and I'll show you kind of some cool things that I've done with bslib and exploring it a bit. So for this one, I'll use Visual Studio Code, but of course it could be anything. So I'll kind of cut to this point. I had created a simple kind of object to define certain theme parameters, and within bslib they have let me see if I have an R terminal here. Nope, I don't. Oh, I always have to remember, if I don't do that, there'd be dragons. I need to create an R terminal here. Okay, and so I got my R terminal set up, and what you can do is in bslib, there is a handy function called bs theme preview, where if you feed in certain theme parameters, and I think there is a default one you can start with, you can get an idea of how your application's going to look before you even start coding it up. So this is a great way to try out those different colors that I found in like that little image scraper thing I just showed you, where I'm setting the background color, this BG, to this. And this, oh yeah, by the way, this is a cool thing about VS Code is that when you put like a color hex code, it gives you this little color picker on the spot. So I could change it now if I wanted to. So that's like a Visual Studio Code thing. And I didn't know that until I started playing with bslib here. So I thought that was pretty neat. And so this foreground color, I think is just basically an off-white. The primary is going to be like a greenish color. And then the font, Yannick in his GitHub repo mentioned that he was using the Oswald font from Google. Well, you can import Google fonts in bslib, which is really cool. And so let's just go ahead and run this, and this should pop up a little theme preview. Okay, here we go. So let's get rid of the Explorer here, and we'll make this smaller. Now, what's cool about this theme demo is, again, you can see how certain inputs in Shiny are going to look with your selections. So you can see the slider input looks like this. Maybe that's good. Maybe it's not good. I don't know. Select eyes input, the date input, and everything's got this nice blue background here. You can then change the color in this preview too if you wanted to. And then, so basically this default theme is what I have put in as like the parameter, but you could also interactively play with these different themes on the spot like this, and it will change it dynamically in the app. So this is the Cyborg theme. And if I can go back to my default, now I got back to the one I'm using. So we can see how tables look, and you can see this is a typical kind of data table from the DT package. It's a very nice background here. And also pay attention to the font. The font is that Oswald font that I put in here in that set of parameters. And now you can see how they look with the heading, the base font, the code font, and you can change some of that stuff over here too. If you go to the font section, and you could play with that here too. So this is an awesome, just this package, like I said, this got rave reviews already. And so many people were excited about it that in the conference, when we were having this kind of social chat area, it seemed like everybody was excited about this, and me included, of course. So this was a great chance for me to play with this. So this is kind of how I started. I got those colors from the image that Yannick had put up. I decided to try making a theme myself and then putting it in the app. So why don't we exit this, getting to know this a bit, and then we'll go back to my Explorer here. So I've got all that set up. So then, as some of you know, I'm a huge fan of the Golem package for wrapping my Shiny apps as an R package. So of course this is Golem, because as my little tagline says, once you go Golem, you never go back. So all my apps are Golem, no matter how big or small they are. So then the next step was, okay, how do I scope out the various UI bits to make this not just somebody choosing numbers from like 1 to 8 and then 1 to 4? How can I make this fun? So that's where I wanted to see, what if I could get from the game, just kind of manually take screenshots of each driver's kind of avatar or head. And then how do I get the cars? And that was just a manual process of me like playing the game into the character select screen, taking a screenshot, going to like GIMP or something and cropping it, and then just kind of saving it out. Oh, wow. Yanni has a good question here. How do you release the R console from a Shiny app running? I actually haven't found that out yet. We can try that again and see if I can figure it out. But let's see. That's odd. Did I do something wrong there? Let's see. Okay, let's try that again. Let me try running the app again. Yeah, so far, I think it's kind of like in RStudio where it's just hogging this R console until you stop the app. At least the way I'm running it in Golem with that run dev script, which is what I always use to launch it. So maybe somebody out there that's used VS Code might know the answer to that, but I'm pretty sure it just hogs your terminal much like it does in RStudio itself, unless you oh yeah, Dean is right on it. As a separate job in RStudio, yeah, that's one nice feature about the RStudio IDE is it has a jobs pane, and then Yanni's clarifying once you stop the app. So what I do is I do Control C to stop the app here, and then the prompt is back, at least in my setup, so then I can do like the ls stuff, and I have all my stuff here. So I don't know if that would work, but I just did Control C. Yeah, and that's, yeah, so it basically kind of stopped the app, I think. So maybe that's the only way I know of thus far. So maybe there's another way besides that. But yeah, okay, where was I? So the user interface elements, I wanted a cool way that once I got those like images of the drivers and the cars to kind of show them. You might say like in like casino games or like in Vegas where you might spin a wheel and then it's just kind of spinning until you land on the final, resting place. I wanted to do that same thing here. And so I mentioned his name already, but then I remembered that my one of my better R friends, Yanni City, has created a package in R called slickR, which is a way to have a carousel of images in your Shiny app. It's wrapping, in fact, let me go back to the desktop view here. So slickR is wrapping the Slick JavaScript library. So again, this is an HTML widget. So you've heard me in previous presentations or other episodes of the dev series mention how awesome HTML widgets are, because they give us all this JavaScript fun in a simple package, and all we have to do is call it in our Shiny apps and tweak some parameters and we're off to the races. Haha, pun intended. So I thought, okay, well, if I had these images, I could do a slickR version of the images and kind of have them moving quickly, and then just kind of stopping it after a certain set of time, and then that would be our selection. So I have that. I had the bslib stuff figured out, and then I'll get to kind of the table stuff in a little bit. That's probably the easiest part. So then I thought, okay, let's start building this app and let's start kind of constructing the bits I need to make all this happen. So the first step was to capture this data that is going to be used as part of the selection process and populating what was selected by the app. And so in Golem, they kind of walk you through some helper scripts to kind of get your dev environment set up. The start script, I don't think I need to cover that today, but the O2 dev script has some helper functions to register certain things. And so what I wanted to do was create a data frame built into the app as the package of the app that we could just interrogate to get the racer name and then each of their cars and their associated statistics. So I figured, okay, let's go ahead and do that. So I created this hotshot data script using the use data raw from use this, and that left me with this script right here, where I ended up just making a huge list out of it. You could have done a data frame, but I thought a list might be helpful in future situations. So I just went through and did this manually. I said, okay, for each driver, what's their name? And I do have an image of them online in my little Imager account. And I actually don't use that for the app right now, but I figured I'd have it just in case. What country they represent, and then their cars, which is another list of list for each car name. So we got like 3 levels deep so far. The car name, the image URL, the type it is. So there are 3 types: balanced, accelerate, or 4 types: balance, acceleration, speed, and drift. And then the different stats associated with it. So it's a simple list, and you can see it. Yeah, it's pretty lengthy, but that's all it is. And then I simply use data on that. So now I have a built-in data frame for the racers. So that, or I should say a list. It's a list. I convert the data frame later on, but it's a list for now. So I've got that set up. And so let's start figuring out, how do I scope out the app itself? So we'll go to the UI side first. And of course, when Golem, those are all created in your R subdirectory here, right out of the box. And then it's up to you to kind of populate them. So let's look at the app UI here. It's nothing that spectacular, but the key point from earlier is that I defined the theme object that bslib is going to use right at the top of the app UI. So it's a simple object called myTheme. It's got exactly the same stuff you saw before. The one thing I did here, because I had some gotchas in my container setup, is that for each of the font Google imports, it defaults to caching it. But I ended up not caching it so that it would always pull it dynamically every time. Maybe I didn't have to do that, but I kind of had to for this one. So then once we get that squared away, we just do our fluid page. It's a simple one. Well, it's got a pop-up window in the bit, but it's really a one-pager of an app. And this was a cool little find I needed to get that background image. Shiny Widgets, which is another great package from the group of dreamers in France. And by the way, we had a great conversation with them in one of the previous episodes of the Shiny Dev series. So shinydevseries.com for the plug there. They have a handy function called set background image. And all you do is you feed in a path to an image, and then this will make your app have that image as a background right in one function call. No need for CSS hacks or anything like that. So I bet you there's a way to do it in bslib, but I haven't figured it out just yet. So I figured, okay, well, if they figured it out, just go ahead and do it there. And then I did some custom things here. So you'll see this first section, it's got a simple well panel. And I end up changing the background color of it to make it act like a box at the top. And so that's what that's about. And that's what the style parameter is about. So that's CSS right there. I'm still pretty new with CSS, but I'm starting to get the hang of where I need to put it in certain places. And then I simply do a logo of Martin and his fun little gaming pose there. And then here I do a little heading of that title. And then in here, this is a trick I've been starting to do in my apps at work, is if I have a paragraph of text, or even say lots of text basically, I try to put that in a markdown file and then use the include markdown function from Shiny itself to render that markdown into HTML dynamically, which makes my code a bit cleaner here, where now instead of me typing all that stuff you saw at the top of the app, I'm simply referencing that markdown script, which I put in this inst app docs folder, and I did a little intro markdown text here. And you can see it's all markdown. I just do a little bolding, a little emoji there in the middle there, and that's basically it. So that to me was an easy way to get the first part of the app going in terms of the top. And then, well, I didn't necessarily have to do this, but I do modules, Shiny modules for everything. So the rest of the app is what I'll call the picker module, the Hotshot picker module. And that's where we're going to start doing some bits. In the rest of the Golem app UI, you can add external resources. And of course, I use Shiny.js for everything. So Dean, there it is again. So then let's go to app server, which will be the easy one here, because it is basically one line of code. Just the call the server side of the picker module, because I'm not The module itself is going to have all the bits it needs to pass things back and forth within it. There's not anything else to this app yet, so I'm not like assigning this to another object. I'm just calling it. So, okay, with that, now it's probably time to dive into the module itself. And so that is right here. So the UI is fairly straightforward. We've got a fluid row. I do like a break, a new, like a blank row to separate the box at the top from the rest of the app. And then we're going to align everything in this full width column to be center. And I just basically have 3 buttons. The launch button, the clear button, and the advance button. The launch button is going to be launching like the whole process. The clear button, that job is to erase any previous selections that the app has made. And then the advanced button is going to show a modal of the different advanced parameters and table that we can let them see. So then separate that out again. And then now this is a function that's come into Shiny from near the beginning, I believe, to be able to like hide things and show things on demand. You have a few different approaches to it. If it's fairly simple, I'm now using conditional panel quite a bit, where you feed in the condition it's looking for. And typically you'll see this to be like input dot some input name to be like, if that input is like toggle true, or if that's like a certain value to show something. But the cool little trick is that you can also put in reactive stuff in here too, if you save it in the output slot. That was a trick I picked up mid last year for my biggest Shiny app ever at work that started to do this kind of thing, and it worked very well for me. So what this is saying is that when we are detecting that we're actively selecting somebody, like that whole process has been kicked off, we now do the slickR stuff. We do one for the driver image and one for the text of their name. Now, Yanni and I are actually having some messages the other day. There's probably a different way I can do this, but at least for now this worked. But I'm thinking of trying something different for that, where you can sync 2 carousels together. Haven't had time to try it yet, but that's in my plan for later on. So then we've got the driver selection. That's in the first column here, this column 4 here. And then the other column is going to be for the car. So we have the driver and the car as these different carousels. And then they're going to spin at the same time. But I will say that the car one's going to be dependent a little bit on the driver or on the random selector, which I'll explain later on. But let me look at the chat here and see if I missed anything. Oh, sorry, I meant to bring the chat back. I'm getting used to my buttons again. Oh, yeah, so Jordan has a comment about he didn't know about the call underscore function. So these are not built into Shiny. These are actually part of Golem. So you won't see this in native Shiny, but what you'll get in a Golem app is this Golem utils UI script, which you can launch on request. And within that, you start to see a whole bunch of helpful functions here. I don't use all of them, but certainly the ones I use the most are the calls. The call underscore 12 is really just a shortcut for saying column with 12 and then putting stuff in. It's just slightly less typing and less indentation and stuff. So I thought, okay, I'll just use those from now on. So another win for Golem to kind of help you streamline your development setup along the way. So, okay, where were we? In the mod hotshot picker. Yep. Okay, so then I did a little tweaking in the width of these. This was a lot of kind of manual trial and error to get it lined up the right way for the width and the height, because what's happening is that when Martin is holding one of our streams, which are typically on Sunday afternoons, my time, but Sunday evening, his time, he actually pulls my app up, this random selector app, in his stream on the spot. and hits the button. So I wanted to make sure that the app looked good in his setup. Otherwise, what's the point of making this? I want to make it look good. So I played with these widths a little bit so that it looked pretty good at the 1080p resolution, which is what he uses for streaming, which is typical like 1920 by 1080 you see in most laptop screens or kind of HD monitors. So that was more trial and error to get that squared away. Then the next bit is another conditional panel, or sets of them actually. One is to show the table of previously selected drivers, and we only want to do that if we know there's at least one that's been selected. So that's another reactive, which we'll get to in a little bit. But then I use Reactable, which is a great package that makes these interactive like tables based on React. It's a lot of fun with that. And then another conditional panel where if the user excluded certain drivers from that selection, they would show up on the right side. So this would be on the left, this would be on the right. So again, that's another reactive to determine, okay, should we show that table or not? So pretty straightforward there. Now the server part, that's where things get pretty interesting, and I probably over-engineered this quite a bit. But, well, I'll walk you through what my thought process was here. So first step, I wanted the tidy version of that hotshot data list object. So I wrote a utility function to basically transpose that into a data frame. And I called it gen_tidy_racers, which is in my utils script right here. Yeah, it's really just converting it to a tibble and then doing a whole bunch of unnesting to get it in kind of a wider format to make it easier for like the table stuff later on. So I ended up using that or coding that up pretty quickly. I do also a data frame for the countries associated for each racer. That's like a very simple one just to get like the right flag image and all that. And then I also have one to generate the paths to all the driver image files, which right now in the app are stored in my inst app www driver pics. And so these are just all the images here. So you can see this is Alexa there, and we got other ones there too. So, okay, so that's that. And then now, a technique I've been doing quite a bit is using reactive values to keep track of certain parts of the process and to pass things back and forth between different things of the app. And so I set them to null initially for like the driver and the driver like slickR object for the driver picture and the driver text. Same with the car image and the car text, slickR outputs. I'm not sure if I use active slick. I'll have to check. Oh, that's just the check if it's activated or not, I believe. Car files and yeah, so I'll have to refresh my memory on some of this. Also, for if they excluded drivers, define which ones are excluded there. And then if I'm showing stuff or hiding stuff, and then a timer to kind of do like how long the process is going to take, and then whether something's active. And then here's where you saw in those conditional panels the active random and the show selected table. These were simply checks to see, okay, is there anything active right now in that we also have a driver that's been selected. So that's going to show if either one of these are true, if we've had at least one driver selected, or that we have an active process going, it'll show that carousel of the drivers. And then also for that showing the table, who was selected, it's checking if we have somebody in there already, which means that this is not null, and that we are able to show it. And so this will only show if we've had at least one driver selected. So that's that. And then this is where, for showing the excluded table, we check another reactive value to check if it's not null. And if it is, we don't show it. But then the key when you do this sort of stuff is that you have to not let these be hidden kind of in the Shiny process scene. You don't want to suspend them when they're not visible. You want to make sure they're ready, and that's where this whole suspend when hidden equal false is about for the output option. So it's saying for these three things, make sure they are rendered at the time the app is launched, even if they're not doing anything yet, but at least render them so that we're ready for that. Okay, so this app, the order is a little off here. This is something where this is going to be like a timer that's invalidated every second, where it's going to basically, in fact, it's probably not good to look at that one right now. Let's look at some other bits first. We do use Shiny.js to toggle certain things, like the launch button. I'll get to that in a little bit. So first, we want to do a reactive for that slickR widget object that holds the images of the drivers in that carousel. And so I did a couple of things here. If I was going to do the web version of a link, I used per to code it up as like an image tag in HTML. But if it was just from the files in the package itself, it would just use the image files. So that's kind of a future proofing thing. And then I simply define the slickR object for the driver files, which are likely image paths, give it an ID, and give it its own width and height, which again, I had to play with a little bit. And then for the second carousel of the names themselves, I do a little trick as well to make that an HTML type text where I get the names of those drivers from that list object. I don't know why it keeps hovering over that. So I get that from that list object with hotshot data, and then I use map again to say, make it a tag of P for a paragraph, I think is how they spell it, and give it a style where the text color is red, and then the font size is 40 pixels. So that makes it so that the text is big enough when he shows this on his stream. Oh, yeah. That's a good joke from Monica. Since one of the drivers is named AL, I'll say, all of your little echoes out there are probably going crazy. So sorry for that in advance. If I totally forgot because I don't have one. Anyway, so after I made the HTML version, I did this xtext DOM, which is simply using a function that Yanni put in called slickList to kind of make all these assemble together. And then now I have another slickR object with this. And then the settings where I don't want the arrows to show up. I want the arrows to only show up. Actually, I probably shouldn't have the arrows for anything, but I didn't want them for the text for sure. So I disabled that. Yeah, so Yanni has a good comment. If I do this, if I sync them together, I'm just going to put a comment for future me here. It would kind of look something like this. It would look like XX and then X, and then there's an operator he puts in called sync, and then it would be then X X2. Yep. So I'm going to try that probably in the future once I get through some other stuff with another app. I'll probably give that a shot. So now what I do next is I update the reactive values for each of these after it's made, because we're going to use those later on. We're actually going to use them in the output slots for those different render slickRs, like the shiny rendering of where those slicker carousels are going to go. And all I do is I simply reference those reactive values, but I make sure that there's at least an object and a reactive value for each of them, for these two anyway. The car one's going to be a little different, which you'll see in a little bit, but basically I still render the reactive value associated with those. And then now we get to what happens when you hit the start button. So I told you this was super engineered, so it's living up to the name here. If they hit the start button, that's an observe event, input start. Then I want to make sure that we have a driver slick random variable already available. And then this is where I don't want to show who was selected at this point. That's why I'm setting this reactive value to false, because technically speaking, what's going to happen is I'm picking the driver in this observe event before things start spinning. So I would be giving away the answer if I showed it, that table, while it's spinning. So I want to hide it and then show it when it's done. So this is, again, my kind of brute force way of doing it, but I figured it works well for me. So I do some, I make sure that if there was anybody that was excluded, that I exclude them here. But we'll get to that in a little bit. And so, yeah, this is the function here, the HS select. I have a function called random hotshot. This is what's actually doing the random selection, and it's really not that fancy. If I go over here, random hotshot, all it does is it gets the tidy data frame of the drivers. And if there was a data frame of excluding other drivers, I take them out of the available choices. So that's what the filter statement's doing here, so that their cars are not part of my data frame here. I set the seed if it's supplied, and really it's a simple call to dply or sample n of the data frame for the first row, for one row, because each driver has a different car. So technically there are 32 cars to choose from. So I'm literally just taking one row from that data frame, and that's what sample does. And I simply return that data frame back of the one row that was selected. So it's really nothing fancy. Although I think in the future I could do some fun things with like maybe a stratified sampling, or maybe make it so that certain cars have a more likely chance of being selected. Because there were some on the stream last Sunday who thought that drifter cars were being selected more above others. But I'm telling you, this is proof I am not weighing any other types of cars in this. I'm just doing it 1 out of 32, equal chance. So that was a fun little thing we had going there. So okay, we got the driver. That's what this is about. And then I simply, if we already had a selected driver, yeah, well, you know, you can look at the code. It's on GitHub, Monica. So we have, if there was a driver already selected, we're going to bind those together with dply or bind rows. Otherwise, it's just going to update this driver selected random reactive value with who was selected. Then we simply parse out their name, their type, and their car name from that data frame. We then obtain the index position of the driver name, because this is important, because slickR, if you want to reference an image by its position, it starts at 0. And Yanni can correct me if I'm wrong with that. But so I had to figure out, okay, in the names for the driver vector, which is simply the name of drivers as ordered in my data frame, which one is the one I selected, and then -1 of that index. And then that is going to determine then when that random selector is done in spinning to get the right image. Otherwise, it would go one more than the actual driver. Yeah, so that's why there is active. Okay, I'll have to check that in mind next time too. So then once I have that index, I then generate a custom car data frame. But what's happening is I am kind of having fun with this. In the car carousel, I don't want to show all 32 cars because it won't even loop through all of them in 3 seconds probably. But I wanted to make it also so that each time driver is being selected, there are potentially different cars being shown, but there's one car for each driver being selected. So like it's showing 8 drivers in that carousel. For the car carousel, I wanted to show 8 drivers, cars, but 1 car from each of them, but make sure that at least one of them was the car that was going to end up being selected. So technically, when you see the cars being spun, one of those is the one that's going to be selected, but then 7 are also just the random ones to fool you and make you, not sure which one's going to get selected. So that's what that gen car df function is going to do. It's going to take into account who I selected as a driver and then randomly pick cars from the other 7 drivers and then add the car that is being selected based on my function earlier. So that's what that's about. And then I form the car slickR objects because now I've dynamically defined what the cars are going into this. I'm almost laughing at myself because this is the most over-engineered thing I've done for such a silly thing. But it's fun building it when you figure it out. So there's the car slick, the car text, and again, like to Yanni's point, I'm going to try and sync these up next time. And then I define certain things here for the random variable, for the driver, or reactive value for driver slick, driver text, car slick, car text, and then I set this active to true. So that active to true is important because now I can show you what happened in that invalidate later stuff. So what this is doing here is we are going to check if we are flagged as active, and reactive value is active like true. We are going to every second take the timer and subtract 1 second. So it might start at 3 seconds, then every second is going to take 1 off. And then if we find that we're less than a second away, we're done. Or if timer less than 1. Oh yeah, I think I missed a step here. I feel like I missed something. Let me see here. I missed. Oh, this was important here. The reason I did these over here is because I had to make new versions of the driver slickR carousels and set autoplay to true and the autoplay speed and the other speed, I believe. I forgot the difference between them. But that kicks off them moving like interactively. I forgot that detail. So after all this random selection is done, it's going to kick off them spinning. And then that's when after they're flagged as spinning, I set this to active to true. Then we go back up here and we go back here. And when the timer is done, when this timer reactive value is less than 1, I make sure that we're set not to active. And then I redo those driver select RVs, but add the settings for autoplay false, infinite false, and the initial slide to be that index of what was selected. So it's all coming together at this point. This is saying, okay, change the option, make sure it's not infinite scrolling. I don't think I had to do that, but I just wanted to be clean. But the important one was the initial slide. So that's where I wanted to make sure it would get stopped, so to speak, at the right place. And then I update everything else accordingly. I set the timer back to the 3 seconds or whatever seconds were in there. And then I make certain other things as null because those are going to change again next time we hit the launch button. And so, so that's all that is. And then when it's all said and done, the other bit that's in here is to create a table, which I'll show. Let's see. It's kind of towards the bottom here. Oh, select the driver DT. It's actually a bad name. It's not a reactable version of it. But I check if we have a driver selected reactive value, which is like that data frame of the drivers that are selected. And I have a utility function called genRacerTable that takes that and basically assembles it as a reactable table, which is right. Whoop, I went too far. Let me see if I put it in a different. No, it should be in here somewhere. genRacerTable. This is. No, that's not it. That's a different one. Oh, where did I put that? Utils. I should have it here somewhere. Random country. This is it. Oh, genRacer. Yeah, was it? Okay, I got goofed there. So Reactable has a whole bunch of parameters you can feed into it to style it up. But one cool thing I did is I made it so that the column for the driver had a custom definition for the cell of it to say, to put basically the country flag next to their name. And then make a div in Shiny. There's the div function, which is kind of like in CSS, a div container, to make the image of it and then put the text next to it. So if I go back and I'll kick off the app again, that's what you are seeing right here at the bottom is in Reactable, I styled that cell so that the flag appeared first and then the name. And that kind of makes it nice like the other the game itself where it has the flags next to each of their names. So there's a lot of styling in this app, probably the most styling I've done in a while, but it was a lot of fun to put all this in. Okay, so there really isn't much more to it. The advanced setting, all that really did was bring another reactable table, but the styling is exactly the same. And so it's really not much to show there. But, okay, so that's basically the first half of this whole pipeline is the over-the-top, overly engineered random car selector. So that was fun, wasn't it? But there's a lot more to this. There's a whole different step to all this pipeline that I want to talk about now. Oh yeah, Howard's asking if this is recorded. So yes, every stream I do is available on demand literally within, say, 20 or 30 minutes after it's done. So YouTube automatically records it, so you'll be able to catch it later on. So yeah, but thanks for coming for that, and hope you learned something fun there. Let me tidy up some stuff here. Okay, so there's another step to all this, is we want to not just have fun with this random selector bit for the driver in the car. I want to keep track of all these results. Now, these results are captured at the end of each race. You kind of saw in that little video I shared earlier, where there's a table of the standings, and it's an image file. So this gets to my next point. I have another app that my plan for this, and starting basically this coming Sunday, which I believe is going to be our next race, is I am going to, in real time, right after the race is done, capture the data and update an online repository to keep track of all the results. Because I'm a stats guy, I got to do this, right? So we're going to jump into some principles that I thought about to get this information. So there's a little bit of bad news in all this. This game, this Hotshots Racing game, while the game is going online, up to this point, there is no API available to grab this information. And so that is it's not ideal, because there's no like great way to scrape it like you might do in other websites with sports statistics or sports tables. We've got to somehow get this from the image file. And so this gets to kind of my next step, is figuring out a way to get this information and extract it and put it somewhere. So for that, let's start transitioning into some exploration I did that was really inspired by an awesome blog post from Thomas Mock, who works at our studio. He's been very forthright with some of the things he's been learning online. He had this post recently, which I found through my other effort called R Weekly. I'm part of the curators there, and this is one of the links that came through. This post about reading tables from images with the magick package. And this post is really a fun read. You should definitely check it out. I'll put that link in the chat now if you want to see that. But he goes through how he was able to scrape some sports data that was sent in like a picture in a tweet of various, I think this was football stats, if I recall correctly. Yeah, sacks created. And he went through how to actually grab all this. And so we're gonna kind of follow a similar process as he did for the screenshot of the race results. So maybe this is over in engineering as well, but it was so inspiring to my companion developer here, Yannick, that he's trying the same approach for it as well in his setup. So this, I guess I spread the good word of automation, I guess. So what I'm going to do here is I'm going to switch some bits here, and I'm going to go to our studio now, and I'm going to walk you through a principle that I think doesn't get enough attention when you start developing ideas for these apps. If you have some business logic or kind of back-end processing that you want to figure out, this is something that I need to do more often, and I'm about to do it more often. But in the engineering production Shiny Apps book from Colin Fay and the team at thinKR, they advocate a really novel approach of, instead of coding up the app right away, try doing the business logic just in a regular R markdown document. And you can add your notes as you go of how things are performing and use that into your eventual application to basically make that development process much easier. And that's what I'm going to show you here is my process for extracting the data from these screen images so that I have the potential to have what I'll call like a data entry pipeline that mimics maybe some processes you might have at your day job or your research, where you're grabbing data from some source, you need to extract it, you need to process it, and then you need to send it somewhere so that other tools or other things can consume it. And then you can, make that all as much automated as possible. So this is my version of that for a virtual racing league of all things. So, so what follows here is a vignette in my other app repository, which I haven't committed this R Markdown document yet, but I probably will after the stream. But the idea is that this is where you probably should start if you know you're going to have to do something pretty complicated. And technically speaking, you can prototype this outside of Shiny first, and then you fold it in later on. So let's walk through this. So the goal of this is to extract the data from this screenshot here. Now, if you're looking at this in our studio like I am here, you notice something about this R Markdown document. It looks like it's the rendered version. What you're seeing here is another awesome feature that got as part of the 1.4 release is the interactive R Markdown mode. So by default, most of the time, you'll see something like this in your RMD file. And you will see, yeah, see you later, Yanni. Thanks for joining. You will see this kind of view usually. But in the interactive R Markdown mode, which is this little button up here at the upper right, you click this, and now it turns into this kind of rich text-like editing experience. And it's really great for situations like now where I'm trying to show some nice narrative styled well for this stream and still be able to write it as if I was writing a traditional R Markdown file. So this is my first time doing it, actually, is for this. So I'm going to do it more often, actually. So the first step is we want to extract the standings from here. And I kind of mentioned in the document here, I could just whip out a spreadsheet in Excel or LibreOffice and just kind of type them all individually, one by one. But no, I don't want to do that. I want to automate this. There's got to be a way. And after seeing Thomas's post, I thought, well, if he can do it, why can't I? Now, what follows next is kind of like the principles I took to get this happening, but it's definitely not the same as the process that he took, because I had to do a little more workarounds than he had to do. The first step is that this is taking advantage of the magick package, which is a wrapper to the ImageMagick graphical processing utility, which is available on all the operating systems, but this is being run from Linux, so it's available there too. And what you do is you simply import that image file of interest. So I have all these standing screenshots here. And then I use image read from that package. Then they have a handy function to render the image as a ggplot. So that's what it is right here. So this is basically the same image as what I did here when I embedded that image directly in Markdown text. So that's all that is. And so I'm thinking, okay, maybe the first step is to take this region right here where I've got the table data, but I don't want all this fluff around it because there's no need for it. So the first approach, I thought, let's crop that image. Let's crop it using ImageMagick's image crop function from the magick package and define the area for the cropping. So this is kind of like the width and the height in pixels. And you may be wondering, why are these numbers so big? Is because when I take these screenshots, I'm running this as 4K. So the dimensions are rather massive, like 38. I have to look up on my other screen here. What is it's like 3840 by 2160. Yeah, so that's a lot of pixels, right? So I want to crop it. And this was all trial and error to figure out the width and height here. So I simply ran those. And then I got what looked like a pretty decent crop. Now, one thing I should note is that each Grand Prix should ideally have 8 racers. So I wanted to leave an extra row here for a row 8 for the future, even though there's nothing in it right now. But I feel like I've cropped it well enough that I got rid of most of the fluff. Now, what happens when I try this with OCR? And what is OCR? I should take a step back there. OCR is basically text extraction from images, and it's using Google's tesseract engine, which has an R package called the same name, tesseract, made by the R OpenSci group. And so and that has direct integration with Magick, so that I can feed in a simple function called image OCR at the end of this pipe and see what happens when I do that image crop. But you notice here, this is a whole bunch of nonsense here. This is like EE/NA. I got some names here and I got some times here, but the rest is all just a bunch of junk here for the most part. So that didn't work as I wanted. But what I didn't do in this first pass is that Thomas had recommended that we convert the image to a grayscale and try to minimize the noise that color makes in these images. So that's what I do here. I start after the crop, I use a function called image quant size and image transparent to say, okay, I'm going to change the color space to gray, and I'm going to try making that like the background of it kind of transparent with a fuzz parameter, which is kind of like how far that image is or that color is in distance from the main color. I have to look it up again. And you see here that doesn't quite work the way I want, because look what happened here. This part got converted to really white with the whitish font. This was still dark with the white font, so that's probably going to mess things up. So each cell is not quite one-to-one with each other. That's not pleasant. So I think, and the other factor is this table is not like straight up and down, it's slanted, which kind of stinks for all this. So we probably need to do a different approach. And that other approach is grabbing the individual cells instead. And so that's what I'm doing here, is I'm simply now going to parse each cell individually of the name and the time and try extraction from that to keep it simpler. So that's what you see in the first block here, is I'm changing the geometry area to be much, much smaller, much different offset, so that I can get, in this case, my name at the top there with what looks like just some orange background and white text. So I think what they do is they'll highlight your name if you're in the online game, to highlight your name in orange for the background to show where you ended up in a more visual way. Okay, so we got that. That looks a lot better, but now let's try the whole grayscale and transparency stuff. And you can see with the same kind of functions where we have the outline of the letters here, but the font is still kind of white. So I don't think that's going to work as well. What can we do to get that converted to like black text instead? And that's where you can actually change the image background to black and then negate it, which basically means flip it around. So what would happen is if I had stopped at this point, it would simply, in fact, we can run this and I'll show you the difference here. Hit play here. Now it's got black and white, but all the tutorials I read online said it's much easier when the font is darker and the background is lighter. So that's where negate comes in. Negate basically is like flipping all this. So I run that, and now it's black font, white background, and sure, the font's a little slanted, but this probably has a better shot at being picked up than the other attempt. And let's see what happens. If I feed that into image OCR, we get my name with a new line character in, which I'm okay with because that can be removed later on. Now let's see if that same thing works with the image race time. Well, kind of. The background's gray. There's still like a hint of white around the letters or the numbers, still with mostly black font, but I feel like it's probably good enough. So let's give it a shot. And sure enough, in here, I do get 0256,499, and then the new line character name, which again I can strip out, but that's great. I think now I've proven that when one cell for the name and one cell for the time, I can get these out. Now that's going one by one by one. So there's basically, if there are 8 racers, 16 cells that we're going to have to get here. Well, let's do this in an iterative fashion. Since the function is basically the same, maybe the parameters are different for like the width and the height and the offset stuff, but we're doing the same thing. So this is a perfect case for per package iterative processing. But my trick was to set up a data frame as like input, where each row corresponds to each row that could potentially show up in that standings table. And I indicate the position, so it goes from 1 to 8. And then I'll call this crop underscore name. This is the dimensions in more of the image magick syntax for the dimensions of width and height, offset X and offset Y, which is kind of like how offset horizontal and offset vertical you do. I do that for the name and I do it for the time because they're different where they're positioned. And they might have different fuzz parameters for that whole image transparent function. That was more trial and error at that point. I just tried different things. But the point is that now I have a data frame of all these stuff assembled in a tidy fashion. Now, we can keep the same data frame and take advantage of the per package to simply map through each of those columns and use the appropriate function. So what's happening here is I did some homework after, like as I was going through this for tesseract, to give it kind of a white list of characters to recognize, which I basically did lowercase letters, uppercase letters, a blank space, the colon operator, a period, and all the numbers from 0 through 9. I kind of copied this from somewhere else. I may have copied it from Thomas's blog, and I adapted it a little bit to have this colon operator. But this gives tesseract a little boost to make sure you're picking the right thing. And then now I make a function called getData, where I do the crop dimension, the fuzz parameter, the raw image object, the combo, which is basically the tesseract stuff, and wherever I want to show the cell when I run the function. when I'm doing this interactively, I might put that to true so I can see what RStudio or what the R session is picking up for that image as I go. But then the function is basically the same thing you saw in the code above. It's just putting it in one place. I get the value from the OCR applied to that image object. And then if I want to view the cell, I print it out. And then I return that text that's made from it. So then I begin the extraction, which I take the dim df. Now in this case, since I only had 7 racers, I'm slicing it ahead of time. But I will make that flexible in the app event that you'll see next. Then I do a separate mutate calls where I do player name. It's going through the crop name parameter and the fuzz name as a per map to call because I'm iterating over 2 variables at the same time. And I use the function get data and I feed in the .x for the crop dim, the .y for fuzz, the raw image object, and the combo thing for tesseract. Then I do the same thing for player time, just feeding the appropriate parameters there. I select just the position, player name, player time. I make position numeric for reasons later on. And then for just the string columns of player name and player time, I'm using from stringer the stringer replace all function to replace the new line character with nothing. And then this is your result. You get the position, player name, player time, which looks pretty close. It's not exact, but it's awfully close to what you would see here. There are some differences though. The big differences are that some of these 5 or some of those 3s there are being classified as 5 for reasons I haven't figured out yet. So we know this isn't perfect, but it gets me about 90-ish% of the way there. So the next step for me is I've got this business logic sorted out. Let's create an app, even if it's just for me personally, to automate the process of capturing this data. So let's have some fun with this, shall we? So I am going to show you the app in action, and then we'll go ahead and explore it. So let me get my... I'm not good with the keyboard shortcuts. I should be, but let's show all panes again. Okay. So we're going to run the app with the golem stuff of run dev. Let's run this. I think it'll show up in the stream. Let's see. No, it doesn't. So I need to... something happening there. It's not showing up. That's interesting. I may have to pivot from this. Let me restart it. I'll try one more time. I have ideas. Let me make in Golem an app.r file. Let's see. I'll just add one of these. Okay. I'm going to give this a shot here. We'll see. Oh, connection review. Okay, so I do some little bits here to make it work with my OBS setup. That's kind of odd, but this is why we have workarounds. So what I'm going to do is I'm going to pull this app up in my other window here. And I need to, whoops. Joys of reopen close tab. I thought I had it. Let me see if it's in my tab. Localhost. Oh, I got it. Okay. So we're going to switch views a little bit. Well, we have workarounds. There we go. We are going to run RStudio server on here in my other window. So that's the nice thing about this Docker setup is I can, let me minimize that. I can run this in a web browser that I know can be captured in my debugging session. Okay, so we're going to Sign in here. Okay, Hotshots data. Okay, we're gonna run the app here, and I will show you what's happening. So let me make this bigger. Okay, I actually want to change something here. I want to get that app.r file open again. Let's see, where is it? Where did it go? Right here. I want to run in a browser tab. Run external. Okay, here we go. So, what you see here is basically the first part of this app is basically kind of form information, metadata about the race. And so if this race occurred on Sunday, we would select something like this. In each of these streams that Martin has set up, we will have different Grand Prix. We did the tour last Sunday, so I'm going to keep that. The first track was Marina, so this is actually dynamic based on the Grand Prix selected. There is a direction. You can either do the normal direction or the mirrored direction. And then you can, this is where if we ran my random car selector app, I would then make sure that this is corresponding to the driver that was selected. So it's, in fact, I memorized this because I worked through this so much and then in the few evenings I've had. Number of racers, we're going to set that to 7 because in that stream it was 7. And then we're going to upload a screenshot of the different images. And so I am going to go to my Shiny Dev Series projects, Hotshots data, and now I have all these screenshots in here. I'm going to open that. And here we are. Now, what I do here is on the left is just image magick or the magick package rendering that screenshot after loading. And it's the full thing here. The right is the result of the image text extraction with some of the metadata columns that I put in up here. But this isn't quite good enough. You know why? Because some of these numbers are not being classified right. So like 2D for his second place finish had a time after the seconds of 393 like hundredths of a second, or however that's done. It thinks it's 595. So that OCR is not perfect. It doesn't happen all the time. Like this French guy, that's actually Yannick's handle. His 3 was correctly classified as a 3 here. Big Calm had his 3 classified as a 5 over here. So I feel like I will eventually be able to figure out why the OCR is not picking these 3s and 5s correctly, or picking these 3s correctly, I should say. But I can't figure that out like with a whole bunch of OCR hacking right now. What if I just want to edit these particular cells that need editing and actually just update it in real time within this app? So that's where I have this little checkbox here called Edit Table. And I simply now have a widget that's powered by excelr to say, okay, make a spreadsheet-like widget in here and give me the ability to edit the cells of these after I do the initial OCR so that I can make them correct on the spot. So I can change this to 0393. I can change this one to have the 3 instead of the 5. This one needs the 3s at the end, so 3, 3. And this one is okay, and well, Monica had to leave, but DNF means did not finish, so sorry, Monica. But that got DNF correctly extracted, which is kind of a bonus to me. It actually got that, which is pretty cool. And so each place has a certain number of points, which I have as metadata in the rest of this app. And so it correctly gives 0 for the DNF, and then it starts at 12 for first place, and then goes down by 1 up. And if had she finished, it would have been 6 over here. for the 7th place, and then 5 for the 8th place, I believe. So this is cool. I've got a way to actually, interactively update this in real time. And so the next step would be to upload it to a repository. So, okay, so the app doesn't look pretty. It's really meant for me, because after each race, I want to pull this up real quick, take the screenshot that I just take from Steam inside the racing game, load it here, quickly edit, do a spot check on the times that need to be changed, and then simply update that and then upload when it's done. So what I can do now is I can show you then what the rest of the app looks like from the back end and how I pulled this off. So we'll stop this here. And we'll go to the app UI as well. Oh yeah. Thanks, Sheng Chuang. Yep. Thank you, and happy Lunar New Year to you. He goes by Freeman, actually. Yeah, happy Lunar New Year, Freeman. So let's run. Let's see. What do I want to start with first? We'll start with the app UI. It's actually, this is where, when you're making something for yourself or maybe like a handful of people and you don't really need to theme it up, keep it simple. Now, of course, and this is really simple because all it is a couple modules. It's just 2 module calls, the mod metadata UI and mod entry UI. The entry one's the more complex one of the two. The metadata one's very simple. Okay, so the app server is also pretty simple, but here is some bits that we're going to talk about. What is this online repository that I can use? Well, in the R ecosystem, the R Studio team has created a really handy package. I'm going to pull it up here, called Pins. Pins gives you a way to put, say, a data set or some other object quickly from your R session to a given repository and be able to have other downstream apps or downstream plumber functions or whatever else consume that in real time. And so this was a great chance for me to say, okay, once I get that racing data extracted, send it to a pin board, if you will, and then be able to have maybe an app in the future, say like a racing dashboard for the racing stats, pull that as it's being updated. This is all just stuff I'm using to learn some techniques that might benefit me in my day job, and plus it's just fun. So the pins package was a great way to try this out. So that's what is happening here is I'm registering 2 pinboard repositories, one for GitHub and one for DigitalOcean using their Spaces functionality, which is basically their clone of Amazon S3. Why I'm doing both, I may touch on if we have time later on. I have about 17 more minutes before I have to close up here, so I'll see how far I get. So I called the server side the modules, but this result of metadata module is going to be fed into the entry module. So the entry one is by far the easiest. It's just a collection of standard Shiny inputs. File inputs, slider inputs, checkbox inputs, action buttons, plot output. Now that's actually, the plot's kind of a misnomer here. It's that image magic representation of the screenshot, but it's still technically a plot output because it's from ggplot2. And then also the excelr widget for editing, but only show it if they opt into editing. And then the table output to kind of show what that data looks like just in a typical view. And then there is another tab panel called the cumulative view, which will show all the data from that pin up to that point. So that's the easy one. The mod entry is where some real fun begins. So mod entry has a few things for like the number of racers. Oh, in fact, I have been looking at this. You know what? I pulled up the wrong one. The mod metadata is an easy one. Yeah, I went off order there. all this is a set of some dynamic inputs based on the selection previously. And like the select Grand Prix is the name of the Grand Prix, but then a UI output will randomly get the appropriate choices for the track based on the Grand Prix selected. Likewise for the driver, get the cars dynamic based on what driver was selected. So that's pretty standard stuff. The repo for this is in the description below if you want to check it out, but I'm going to go back to where I was because I kind of goofed myself there a bit. So the server side of this. I'm going to have two reactive values to keep track of certain things, such as the edited version of the table of racing results and whether I've uploaded something. So first, we need the image path to where that image was uploaded in Shiny, and it's in like a temporary area somewhere. But I have a function that Dinatelli actually helped me create called fix uploaded file names, where what that does is by default Shiny will kind of rename these files after it's uploaded. I wanted to keep the same name as the file uploaded, so he wrote this function way back when. It's actually, I linked to his blog post or linked to his GitHub repo if you want to check that out yourself. So that's a little nicety there. Where am I? Over here. So we keep track of the path to that image file. This output preview is simply using a function called view race image, which is simply a wrapper to that whole magic stuff of rendering the screenshot as ggplot2. It's just a friendly wrapper for it. And then here what I'm doing is I'm a reactive for the processed race results. So what happens here is I am making a one column data frame of the image path as to be used later on for an immute call to create a list column called standings table, which is the application of import race image, that same function you saw in that R Markdown document, using the image file, using the number of drivers, and wherever I view the image. So it's like a wrapper of a wrapper, but it just makes it clean so that this reactive is so simple. And then I just unnest it at the end so that now I have that standings table, as you saw in the R Markdown file, right there on the spot. So then I update the reactive value to have that table. And then I assemble the final set to say, okay, take that extracted data frame, take the other columns, and simply bind the columns together. So now I have that whole set of things. In addition to like the standings data, it's got like the date, the track, the driver, all that stuff with it. Then we get to this edit viewer, which is simply using the slickR package, which if you haven't seen that, and contrary to what you might think, it has nothing to do with Microsoft Excel itself. It's just, let me pull up this page and I'll find the GitHub repo. It's basically a way to render an Excel-like interface into an HTML widget. And if you have been using something like R hands-on table in the past, I would highly recommend pivoting to this. Nothing against R hands-on table, but I've had a lot more success with this one recently. So the developer has actually updated a couple issues that I reported, so that was helpful too. But anyway, that's a highly recommended package. Where was I? So slickR has a Shiny component where you use a function called Excel table to feed in your data frame. You can define the attributes to the columns, and then you basically set some other defaults, and that really was it. But then you can keep track of the edits that are done when somebody edits the cells by grabbing the contents of this by using this Excel to R function based on the input that it exposes. I clean up the names a little bit, and then I do a little cleaning on the points and the position columns, and then I update that reactive value based on the results of those edits. Then we display the table here in that little render table just as like a diagnostic. We also do the same thing for the cumulative table, but we refresh it every time an upload's been triggered. Now, upload being uploading to GitHub, not the DigitalOcean thing, not the upload of the image file itself. So that's important. And then we get to the processing for image, getting it to the pin board. That's where I show a notification within the app. I give the image a new file name, because what I'm going to do is I'm going to crop this. I'm going to resize it a bit after I copy it, because I don't want that image to be so large in GitHub or in DigitalOcean. I don't want it to be the 4K resolution. I want it to be downscaled quite a bit. So that's what that's about. I generate a link kind of dynamically to the GitHub version of that image. And then I save the image itself of the screenshot to each pin board, which I'll show you that right now. Right here, it creates a folder for each image. And then if I look at this one here, it's got the PNG right here, and it's a little, the GitHub kind of crops it a little bit in this way, but this is the image right here. All I did is here is I resized it for the pin board. So that's taking care of the uploading bit. And then if we go back here, now let's take care of the data frame part. So what I want to do is I want to first check if there is a pin of the data frame cumulative version already in this pin board. And if there is, I want to grab the current version. I want to bind the rows to the new version that I have. Otherwise, if there isn't one already, just simply grab what I've currently created as like the thing to upload. And that's only if we don't have the override table checkbox enabled. If we do enable that override, it's just going to grab this and change whatever's there anyway. So then we send that to the pin board, that data frame, to both places. And then I also send what I call a latest version of the data, which is basically helping Yannick out if he wants to consume this, to only grab the latest race results if he wants to put that in some kind of automated pipeline. So that's what I do here. I remove the notification that we have an upload in progress. I trigger an upload trigger, which will refresh that cumulative table view. And I simply show a notification that it's uploaded. So that sounded like a lot, but honestly, it's pretty logical in terms of how this is all laid out. So in the end, I have now basically a import and uploading kind of script with OCR for the actual race image screenshot. So I've learned a heck of a lot from this approach, and I definitely want to use it more often if I'm put in a similar situation where my data, just for whatever reason, is locked in an image file or a PDF or something, and I need to grab it out. So this image magick with OCR, with tesseract, is a really awesome combination. And putting it in a Shiny app gives me a way to simply give myself a cushion to edit this if I need to afterwards, if some of those cells, just for whatever reason, don't quite work correctly. So again, we'll show it one more time now that you've seen the code. We'll just upload an image here. We won't change over things. But I'll show you one case where my screenshot was a little off. There was one screenshot that I took where I accidentally hovered my mouse over one of the entries. And because I made this yellow accidentally and everything kind of zoomed in, look at the OCR have a much harder time with the player name and the player time. So if I screw up the screenshot like I did this time, I would definitely click this, and then I would edit these to be appropriate. I would have to do it pretty quickly, but then I would just simply clean that up and then upload it afterwards. So this gives me, again, that cushion if things don't quite work as expected. But, you know, it's better to have that than to not have it. And the last thing I want to do is update an actual spreadsheet if I can avoid it. I don't like spreadsheets. So this is the tech I have built up to this point for this virtual racing league with Martin Wimpress and my friends in Wimpy's World, that he calls it. But I'm not done yet, so to speak, in terms of where I want to go with this. You can guess where I want to go next is I want to now do a dashboard that kind of visualizes some cool summary statistics and maybe some plots of the race results so that it can be like our own ESPN or whatever, like sports network version of stats online, and people can kind of look at all the race performance as we go. But now I've got the infrastructure set up to first help Martin pick a random car before each race. Second, capture the data, put it somewhere, clean it up through OCR and image extraction, and that's going to serve as the repository for my eventual application. So if I go back to this GitHub repo where I've got everything archived, this Hotshots race results is the integrated data. It's in CSV format. You're welcome to download it if you want, but it's got each of the individual races all kind of binded together, each row by row. So there's a block of 7 rows for each race, and they all change the track and the car. Now, what we're going to do in the next round is that Wimpy is going to pick a car, but we're going to use it for all 4 races of the first half. The second half, we'll use what we call the mirrored tracks, and we'll pick a different car for that. So the next round is only going to have 2 possible cars that are used. And we'll see if that changes the results a bit. But up to this point, I don't have the screen capture here, but in the other stream, Yannick had an overall dashboard or an overall table of the results, and I am currently in second place. I had a great first half. Like, I got number 1 in the first 4 races, but the second half I kind of came crashing down to earth, so to speak, and so now I'm in second place. So Martin's first, I am tied with second with some others, and it's actually quite close. So we got a lot to play for. And the funny bit is, even the manufacturer or the company behind the game, their name escapes me right now, but it looks like they're going to offer the winner some swag if we win the Grand Prix, because we're apparently the only group that's doing like an online racing league with this game. And they took notice of it. Martin's been very upfront with spreading the word, and they like it. So that's happening at least every Sunday for the next few weeks. So you'll see me there and trying to go as fast as I can, so to speak. So, okay, that's been a lot. I think that hopefully has been helpful. All the links to the repos are in the show notes below. And if you like what I've been doing here, if you want to see more of these kind of deep dives into what I do in my kind of shiny app explorations and development, I would really appreciate a little help along the way. First, maybe just spreading the word to your friends that are into these things. And if you would be so kind, I also have a little tip jar and a link below if you want to share a little donation. That would go directly into upping the production setup of this whole thing, which is already probably more money than I care to admit. But I want to do some more stuff with it, so every little bit helps. So I would greatly appreciate it. Even if you just say hi and spread the word, I'm happy with that too. So we will probably close up shop. Thanks for those of you that joined online, and we'll see you probably, hopefully, in a few weeks. Have fun making shiny apps and have fun playing with R and open source. We will see you next time. Bye-bye.